It came as a precursor to a brightly shining supermassive black hole that was spotted hiding in an old Hubble Space Telescope data. Even though black holes are prevalent in the spacefaring adventures of sci-fi flicks, they are actually a relatively new find for astronomers. Einstein first predicted them when he published his theory of general relativity in 1916. But these so-called frozen stars weren't coined black holes until 1967. Then, 5 years later, astronomers actually discovered the first black hole. Fast forward 48 years later, and scientists had finally captured the first image of a black hole. So it's no wonder so much about these alluring monsters remains a mystery. But you can be kept up to speed. Here's the shocking details about black hole discoveries made by the Hubble Telescope and advancements of the study via the James Webb Space Telescope. Without a doubt, it's one of the biggest lingering conundrums about the vastness of eternal space. How did supermassive black holes grow to be so large, so fast in the early stages of the universe? Ranging from millions to billions of times the mass of the Sun, these titans reside in the heart of most galaxies. And because there is a limit to how much material they can consume in a single gulp, mathematically, it should take a really long time for them to devour enough to grow to such epic proportions. Yet, how can this be? Astronomers have identified supermassive black holes less than 1 billion years after the Big Bang. This boggles the mind. Now, a new object hidden within one of the best studied areas of the night sky may just hold the missing link to the evolution of black holes that scientists have been searching for. And the Hubble Telescope, along with the James Webb Space Telescope, will shed some light on the mystery. An international team of astronomers uncovered massive black hole GNZ7Q while sifting through the archival data from the Hubble Space Telescope. Lurking within the Great Observatory's Origins Deep Survey North Goods N field, the black hole existed only some 750 million years after the Big Bang. As usual, the Great Black Hole sits at the core of a dusty galaxy exploding with star formation, also known as a starburst galaxy. Gabriel Bremer, an astronomer at the Niels Bohr Institute and co-author of the study published on Nature that's analyzing the black hole, was quoted saying, "GNZ7Q is a unique discovery that was found just at the center of a famous, well-studied sky field, showing that big discoveries can often be hidden just in front of you." Originally, the concept was only predicted by theories and simulations. The discovery marks the first observation of a rapidly growing black hole in the early universe. Such swiftly growing black holes are thought to be an important link between supermassive black holes observed in dusty starburst galaxies, as well as ultra-bright quasars. Keep in mind that among the most luminous objects in the cosmos, quasars are probably the most dynamic and illuminated. They are created as the result of supermassive black holes gorging on gas and dust. The infalling material produces ample radiation across the entire electromagnetic spectrum, emitting thousands of times more light than the entire Milky Way. According to the best scientific theories, supermassive black holes are born in the hearts of dusty starburst galaxies, and given enough time, they consume the surrounding shroud of gas and dust to reveal themselves as extremely luminous quasars. Currently, the inner portion of GNZ7Q's accretion disk is obscured, with the outer part just beginning to reveal itself. If confirmed, that means GNZ7Q is passing through an important transitional stage of life that's predicted by theoretical models. This is an indicator of good science. The hypothesis is being realized. Seiji Fujimoto, lead author of the study, gave his speech during a press conference where he was quoted saying, "GNZ7Q provides a direct connection between these two rare populations and provides a new avenue towards understanding the rapid growth of supermassive black holes in the early days of the universe. Our discovery is a precursor of the supermassive black holes we observe at later epochs. Now there's plenty of work for the JWST. GNZ7Q was found in one of the most thoroughly studied areas of the sky. It was right there under our noses all that time. So this stems more excitement. Scientists are hopeful that there are plenty more examples out there." Astronomer Gabriel Bremer touched on the matter, stating, "It's unlikely that discovering GNZ7Q within the relatively small Goods and Survey area was just dumb luck. Rather, the prevalence of such sources may in fact be significantly higher than previously thought. That's an elegant way of saying the tech found it, and without it, we would still be blind." With that fact being absolutely obvious, in moving forward, the researchers are more than eager to use the James Webb Space Telescope to more closely observe the very early stages of the universe and comb comb over any potential blind spots that may have been previously overlooked. The recently launched James Webb Space Telescope promises to be powerful enough to uncover plenty more of these objects, assuming they are as prevalent as this finding suggests. The enthusiasm also flares as this discovery could be the evolutionary missing link of the formation of galaxies. As the universe is saturated with galaxies, even the weirdest things can go unnoticed for years. This was the case even after the Hubble Space Telescope's deep exposure observations were taken. In sort of an intergalactic Where's Waldo, an international team of astronomers uncovered in Hubble archival data a mysterious red dot nearly in the middle of the Great Observatory's Origins Deep Survey North, GOODS North. As innocuous as it looks, it could be a rare missing link between some of the very earliest galaxies and the birth of supermassive black holes. The celebrated black hole GNZ7Q existed when the universe was just a toddler, only 750 million years after the Big Bang. Astronomers understand that the mixture of radiation from the object cannot be attributed to star formation alone. The best explanation is that it is a growing black hole shrouded in dust. Eventually, the black hole will emerge from its dusty cocoon as a brilliant quasar and pulse its intense beacon of light as the heart of an early galaxy. The pioneering Hubble Telescope has provided a unique target for NASA's James Webb Space Telescope to use its spectroscopic instruments to study objects like GNZ7Q in detail, which should render unprecedented images and data. It's now one of the most outstanding mysteries in astronomy. How did supermassive black holes, weighing millions to billions of times the mass of the Sun, get to be so huge so fast? As touched upon earlier, current theories predict that supermassive black holes begin their lives in the dust-shrouded cores of vigorously star-forming starburst galaxies before expelling the surrounding gas and dust and emerging as extremely luminous quasars. Although it's extremely rare, both these dusty starburst galaxies and luminous quasars have already been detected in the early universe. The team that published the study believes that GNZ7Q could surely be a missing link between these two classes of objects. GNZ7Q has exactly both aspects of the dusty starburst galaxy and the quasar, where the quasar light shows the dust-reddened color. Also, GNZ7Q lacks various features that are usually observed in typical, very luminous quasars corresponding to the emission from the accretion disk of the supermassive black hole. This more than likely explains why the likely explanation that the central black hole in GN7Q is still in a young and less massive phase. These properties perfectly match with the young transition phase quasar that has been predicted in simulations, but never identified at similarly high redshift universe as the very luminous quasars so far identified up to a redshift of 7.6. Remember, a redshift is a displacement of the spectrum of an astronomical object toward longer, red wavelengths. As you can connect the dots, in 1929, the American astronomer Edwin Powell Hubble reported that the distant galaxies were receding from the Milky Way system, and that their redshifts increased proportionately with their increasing distance. He was one of the first people to understand that the universe was expanding. He was such an influence, NASA named one of their best space telescopes after him. As the Britannica would describe it, the generalization for the basis of redshifts became known as Hubble's law, which correlates the recessional velocity of a galaxy with its distance from Earth. That simply means the greater the redshift manifested by light emanating from an object, the greater the distance of the object and the larger its recessional velocity. This law of redshifts has been confirmed by subsequent research and provides the cornerstone of modern relativistic cosmological theories that postulate that the universe is indeed expanding. So, by applying Hubble's law to the redshifts of quasars, scientists can learn a great deal about the light emitting from the center of galaxies. In the upcoming months, the Hubble and its newer counterpart, the James Webb Space Telescope, are due to reveal more answers and questions for the untold mysteries of our universe. Make sure you have a front row seat to the stars. Hit that like button, ring the notification bell, and share this video. For more impactful news about the stars, be sure to head over to the Space Infinity Archive and tune in to the various videos for your education and entertainment. Godspeed, my friends.